So we have already seen McLaughlin's neuron model in the last class. Now we are going to see other neuron model which is called as Perceptron neuron model. And here this name itself says that it is designed by a scientist named as Perceptron Blatt. So this is called as Perceptron neural network. So these are the basic elements that are present in Perceptron neural network, and the basic elements are sensory units, or we can call it as retinal units, and then association units, and then response units, and then from that we are going to connect them to summation block output generation. So coming to the first block, that is sensory units. So here in the sensory units we are going to have n number of values, and that can be images. The values can be images, letters, or any other input format. So this sensory unit basically consists of huge amount of input of different parameters, and that can be any of the images, letters, or any other format of different values. And this huge sensory unit is also called as retinal unit, which consists of the input, n number of input. Now the input from this sensory unit is fed to association unit through network of random connections. So here if you see, this is called as random connector, and the input in the sensory unit will be fed to association unit through n number of random connections. So the entire input is fed to association unit through random connections. And here if you see the huge amount which is placed upon the board, this data is taken out to the association unit. The useful data is fed to association unit through random connections. Now the input or data at the association unit will be fed to response units through many-to-one connections, network of many-to-one connections. The input in the association unit is fed to response unit through many-to-one connections. So here if you see, in the response unit, let us consider the input is R1 and R2, R3 and so on R8. In this example, we have taken 8 number of responses. So here if you see, for this 8 number of responses, the inputs are coming from association units. Association units are giving outputs to response units. So response units basically collects the input from the association units through many-to-one connections. And here if you see, if you consider a particular input, that is fed to R1, and also in addition to that, other input is also fed to R1. In addition to that, not only 2, we can send n number of inputs to each response unit. And now we are sending this input to response unit. Let us consider we are sending 2 inputs to the response units. And the basic format of the 2 inputs, one of the input can be an image, and second input can be some letter format. Both the inputs are fed to the first response unit. In the same way, all the inputs present in association unit are fed to all the response units. Now, in the response unit, so we have considered only two inputs for R1. One is image, other is true. Second one is a letter value. Now, that image and a letter both are converted into same format. Nothing but both are converted into some binary format. Both the image and letter are converted into binary format in the response unit. In the same way, not only for R1, you can consider for R2, R3, R4 and so on, R8, the same procedure will be repeated. And that converted values will be of binary type. And that binary values can be of any one, either that can be 0 or that can be 1. The obtained binary output can be either 1 or 0. So that is obtained at first response unit. In the same way, you will get 1 or 0 by obtaining inputs from association unit at response 2. In the same way, you will get 1 or 0 at response 3 by obtaining input values from association unit. Same way, you will get response 4, response unit 5, 6, 7, 8. We have considered in this example 8 response units. You can consider n number of response unit based upon your load requirement. So here, after converting all the unnecessary input into some predefined format, let it be a binary input, which will generate either 1 or 0 at each output of this response unit. So this is how huge number of input which can be of any format will be converted into binary value. Initially, the entire input will be taken on sensory boards and that is being fed to association. Within the association, some selection of inputs will be done and that selected values are fed to response units. Where within the response units, we are going to convert that into a binary format of ones and zeros. And then the process will continue. So this is also the block diagram for perceptron neural network. So same, it consists of sensory, where huge amount of data is fed to association units. Within the association units, you are going to generate or you are going to feed that to response units, where you are going to obtain inputs of either 1 or 0 at this output of association or output of response unit block. So here, let us consider we have obtained some m number of inputs from response units. After attaining this 8 inputs or m number of inputs from the response units, which is of binary format, all the inputs now transferred to summing unit through weights, through synaptic weights. Let the weights be W1, W2 and so on Wm. So the converted binary format based inputs are transformed into summation block through the synaptic weights. Now, what is the output you will get at the summation block? At the first input, you will get A1 W1 or you can write X1 W1. Second value X2 W2. Third value X3 W3 and so on Xn Wn. So this is the basic difference between McLaughlin model and also Perceptron neuron model. In McLaughlin model, the data will be of one type, which is of binary type. Either the input can be 1 or 0. That is directly taken. Whereas in Perceptron model, the input data can be n number of types. And the entire input data is transformed into one format of ones and zeros. Now, this ones and zeros converted input is transformed into summing block through the synaptic rates. And input is x1, w1, x2, w2 and so on, xn, wn. So, once this is attained, once the input is obtained at the summation block, the entire input data will be summed up and then xnet will be calculated at the output of summation block. And this xnet can be written as x1 w1 plus, as it is fed to summation block, you are going to add the entire value x2 w2 plus x3 w3 and so on plus xn wn plus some bias value of b. And this can also be written as xnet is equal to summation n is equal to 1 to infinity xn wn plus a bias value of b. This is the output at the summation block. Now, this xnet is passed through a binary step activation function. So, this is passed through binary step activation function. What is binary step activation function? So, it is a function which consists of x and f of x. It will generate either 0 if x greater than or equal to this reference value of theta. Then it will generate f of x as 1. If it is less than theta, f of x will be 0. So you can generate either 1 or 0 by using this binary activation function. By comparing this xnet with the activation value or threshold value, if the calculated xnet, which is equal to summation n is equal to 1 to infinity xn wn plus b, if that is being greater than or equal to theta, here the theta is activation value of the activation function. If that value is greater than considered activation value of activation function, then you will get output signal, again that is a binary value. You may get output value as 1 or 0. So here if this xnet is greater than or equal to theta, output is 1. If xnet is less than theta, output is 0. So you get output of the perceptron neural network as 0. And this is called as perceptron neural network. This is the entire operation that is being performed in perceptron neural network. So let us take an overview. Perceptron neural network basically consists of 3 units before performing normal operation, and the 3 units are sensory units, association units, response units. So what is the use of this sensory unit? The sensory unit basically consists of huge amount of different data. Huge amount of different data. That is in sensory units. Now, that huge amount of data may consist of necessary data, or it may contain unnecessary data. So it may contain necessary data or it may contain unnecessary data. Now, within that sensory consisting of huge amount of data, that is fed to, within that you are having necessary data, unnecessary data. Now, the necessary and required information will be taken out from this sensory units through interconnections called as random connections. So, the necessary data will be taken out from this sensory units through random connections. Now, that information is fed to association units, or we can call them as association block. So that information required or necessary or useful information is fed to association units through this random connections. Now, within the association unit, the information will be processed. The information will be processed, and that processed information will generate some output value which is of binary type, and that will be either 1 or 0 format. Binary format, 1 or 0 format. Now, obtained value in the response unit will be fed to the artificial neural network through, so this obtained binary input values will be this. Now, these are fed to the neural network structure through synaptic weights. Through synaptic weights. Now, the input with the synaptic weight will be summed up at this summation block, and it will generate net value at the output of the summation block. So, it will generate net value at the output of summation block. Now, this net value is fed to activation function, which can either generate 1 or 0 based upon comparison that is being done this X input with the activation value present in activation function, and it will generate output value as 1, or it will generate output value as 0. This is about perceptron neural network. Next, third type of artificial neural network is Adaline neural network. Third type is Adaline neural network. Here, Adaline is nothing but adaptive linear neural network. What is Adaline neural network? Adaptive linear neural network. Nothing but the name itself says that adaptive linear activation function will be used in Adeline neural network. So, the name itself says that adaptive linear activation function is used in this Adeline neural network. What is linear activation function? So this is the basic graph for linear activation function. X-axis represents x minus x. Y-axis represents f of x. And here the linear activation function, for this linear activation function, output is a linear value. Nothing but if the input goes on increasing, f of x also goes on increasing in the positive direction. If x goes on increasing in negative direction, f of x also goes increasing in negative direction from point of 0. So this is called as Adeline neural network. So here Adeline neural network will generate positive value if x is greater than 0, generate a negative value if x is less than 0, or the expression for this linear activation function can be given as f of x is equal to x for x greater than or equal to 0, minus x for x less than 0. Or else you can write x itself, whatever may be the x value you will get, that can be a positive or that can be negative. That is generated as output f of x. So that is called as linear activation function. So whatever may be the x-net value, that x-net value will be obtained as output of linear value, output of this linear activation function, or that is obtained as output of adaptive linear neural network. So that is Adeline neural network. So Adeline neural network is nothing but adaptive linear neural network which uses linear activation function for computing output at the output side of neural network. So here if you see, linear neural network or linear activation function will generate output same as x-net value. That is called as a linear activation function, and that can be any value. Whereas coming to McLaughlin neuron model and Perceptron neuron model, here it will generate in Perceptron and McLaughlin, it will generate 1 plus 1 if that is greater than or equal to 0, generate 0 if that is less than 0. Because in Perceptron and McLaughlin neuron model, step or binary step activation function will be used, which generates either 1 or 0. Whereas in case of Adeline neural network, it will generate output value same as x value. So here y of x, that is output, will be same as x. If x is positive, we can get y of x as positive. If x is negative, we can get y of x as negative. So here y of x will be decided by x net value, because here linear activation function whose graph is a pure line is being used in Adeline neural network. Now coming to structure of neural network. Basically neural network consists of inputs. Not only P1, P2, you can consider n number of inputs. Let us consider x1, x2 and so on, xn are the inputs which are being fed to the neuron through synaptic weights of W1, W2 and so on Wn. So here in the example we have considered P1, P2. Not only P1, P2, you can consider n number of inputs. Now what will happen? The input is being passed through synaptic weights. As we have considered two inputs, we have considered two weights. If the neural network consists of